today I'm here to talk about Multicloud CI/CD with OpenStack and Kubernetes. And yeah, I'll introduce myself a little bit. I'm Maxime. I'm a system engineer and cloud consultant. I help customers to be successful with their public and private cloud projects. I specialize in OpenStack, Kubernetes, Ceph, and CI/CD. And that's enough about me. We can dig into the topic, right? So the presentation is multi-cloud CI/CD with OpenStack and Kubernetes. But what do we mean by multi-cloud? First, let's put the landscape. So multi-cloud is like the fact of running across several clouds. And we might have several motivations for that, and that depends a little bit on your organization. One of the main drivers is to have several providers for instance, for resiliency. Happens every now and then in the news. One provider has a huge outage in one region, and you don't want that to affect you, so you would run across like several regions. Another case is vendor lock-in, so you could want to work with different vendors to avoid lock-ins with one specific vendor. And that's valid for the big three cloud providers or for OpenStack public cloud providers as well. It's always nice to have flexibility to work with several vendors, so you can be flexible. If one vendor does something you're not really happy with, well, you can scale down your infrastructure there and scale out into the other ones. So it gives you like some business agility. It revolves also around cost for some organizations. It can either be that they want to take advantage of the cost difference in different clouds. Maybe one provider has a better price on object storage, another one on compute infrastructure, and things like this. So you might want to leverage the best price point into different providers. Or it could be that you're targeting to do a hybrid cloud setup where you have your private cloud based on OpenStack running in-house, handling all your baseline load on your application, and you would do handling all the load spikes into one or several public clouds. So that could help out on the cost sides to handle only the spikes into public clouds. So there are like lots of cost dimensions into the multi-cloud area. Oh, that's not good. The last point was around locations and features. So you might have different cloud providers that provide different features. One cloud provider might be really good at providing GPU-based machines. Another one might be really good at having big data things, or having Sahara for helping out your big data initiatives. Oh, it could also be locations. The big three providers or the big three giants, they have a set of locations, and you might be fine with those locations, or maybe you want some other locations that are maybe closer to where your customers are. So that could also be a motivation to have some other locations. So those are kind of the motivations around multi-cloud. The next keyword in this is CI/CD. So why do we want to do CI/CD, or why is it interesting to do CI/CD? Usually it's to be able to fail fast. Like, we want developers to be able to experiment things really quickly, and to be able to try things out, see if it works out or not, and then move on. We don't want to really have to involve ops team or have to call people and, oh, can you set up this dev environment, or testing this new feature and so on. We want to be autonomous, be able to do things on our own, automated and quickly. That allows to be more agile. That goes into hand in hand with automation. So for this to work, we'll need automation in place so that we can do the continuous integration and continuous delivery automatically on every commit or every push. So the continuous integration would happen for every commit into a topic branch, for instance, if you are using Git, and the continuous delivery will happen into each merge request or pull request if you're talking GitHub, or once your code is into master, it would go to production. And that should happen automatically to save time and energy, basically. It's also a consistency dimension with the CI/CD. When we have lots of locations and lots of clouds, you want to make sure that you're consistent on how you do things in those different locations. If you have people handling the deployments or the installs, you're going to have slight differences every now and then in different clouds. It might be really difficult to identify those differences, and you might run into problems later on. So that's kind of the drivers for going CI/CD here. And then the last parts are OpenStack and Kubernetes, and they really go well they work really well together, hand in hand. We go with OpenStack to provide an API-driven infrastructure, and API-driven is really important because otherwise it's going to be really hard to do automation if we don't have APIs. So that's like the key element for OpenStack, but also the open infrastructure side of things. OpenStack gives you one API that works across your private cloud as well as many different public clouds. So that's really valuable, whereas if you would go with the three giants, well, they each have their own APIs, and you would have kind of to play with 3 different APIs, and that's not really fun. So that's kind of an interesting value proposition there. OpenStack also has a pretty big ecosystem of public cloud providers. There are around 60 availability zones across the globe. There is like a marketplace page that lists them all, and you can compare different features that they might have, different versions of OpenStack they run, and different locations where they are. So that's like really interesting for the consumers of the multi-cloud. On the Kubernetes front, Kubernetes is really like the container platform, container ecosystem, and it's more developer-centric, so that we're going to be able to make things easier for developers. They'll be able to run Docker on their machine, they'll do a Docker build, and they will have the same deployment as what we'll have in production or staging, basically. So that makes things really easy and really easy to reproduce. That's really important when you're want to have CI/CD, right? So that's the overview picture. So on the left-hand side, you have your users that are going to talk to your application. And so your application is you have your business logic. Your application runs on Kubernetes into a container, and Kubernetes runs on top of OpenStack. So this is kind of your data plane where all the customer traffic goes. And on the right-hand side, you have your control plane. This is where your developers or your DevOps will work. They'll work towards the CI/CD platform, and the CI/CD platforms will do the necessary actions in your application, in Kubernetes, and in OpenStack to make the magic happen, right? So we're gonna create containers, pods, VMs, and all that stuff. That's kind of the idea. Separate the control plane from the data plane, and that's very high-level overview of it. I see some people taking photos. All the slides, they are available online, so there's the link at the end if you want to check later. So that's it for the introduction. Now we'll go a bit more into the specifics of the architecture I'm demoing today, and that's the architecture I'm doing. And you might tweak it to whatever you want. It's just one way to do things. It's not the only way. So we'll start at the edge. So your users, they will enter a DNS name to access your application, and that's really like the entry point for your users. They'll enter this into their browser, and this is like the first step for them. When they enter the DNS name in their browser, we want to have some form of global load balancing happening. So since we have several cloud providers working hand in hand, we'll need to be able to route traffic from one to the other. And for this, we kind of have 2 main options. We could go with a CDN, and you might already be using a CDN today, so that's a content delivery network. If you do, then you can already leverage this to do this global load balancing. If you don't use a CDN or don't want to use a CDN for some reason, you could do some DNS configurations. So you have some providers like Route 53, so that's part of AWS, and you have a DNS that allow geo-routing DNS technology. So that allows that basically tells the client to go to the closest server they have to them at the DNS level. You could do some DIY dynamic DNS configuration, or you could do things as simple as DNS round robin. Kind of different option. Choose what fits you most. Once we are load balanced, we're gonna hit different instances of the app. In this case, I have 3. It's just an example. What's important here is that the application needs to be what we call a 12-factor app. So that's the famous 12-factor principles. And that's really key. We can't really do that with applications that are not suited for running in active-active mode, for instance. If we want the applications to run in Kubernetes, we'll have to have it Dockerized. So make sure your application is Dockerized or possible to be Dockerized. The application needs to be HTTP-based, so some form of web app or API-based, REST API-based application. Otherwise, we won't be able to use a CDN, for instance, since that's only HTTP. And it's really important that the application allows to run in like a distributed fashion, active-active. So those are like the key elements on the application side. Now, the application runs on Kubernetes, but you could imagine many different ways to run the application of Kubernetes. What I suggest here is to use Kubernetes as a cloud abstraction layer that will abstract things, abstract the infrastructure for the application. So it will give more developer-centric constructs to the application. It's important to do one cluster per location. We should not do like one cluster across several data centers. That's going to create lots of problems, and most importantly, it's going to make issues with the resiliency goals we had earlier. Like if we have one giant cluster, we have one giant failure domain, so that doesn't really fit with our resiliency goals. We'll use Kubernetes ingress, and that's gonna take care of the HTTP translation. So we're gonna ingest the queries with the ingress and then forward that to the correct container into the cluster. So that's what the Kubernetes ingress does. And it's something that comes in directly into Kubernetes. And since we have many Kubernetes clusters, here just 3, but you might have many more, we'll need some form of federation to make things easier for ourselves. And here is where things gets a bit complicated. So if you talk about federation, if you come from an OpenStack background, you probably think about keystone federation or identity federation. So Kubernetes has support for that. It's called authentication federation, and you have 2 main options there. You could either use OpenID Connect as a identity provider, and there are lots of identity providers that support that. You have GitLab, GitHub, Google, and probably hundreds more. And the configuration here is really easy. On your Kubernetes API server, you set those 2 options, OIDC issuer URL and OIDC client ID. And that's enough for your Kubernetes cluster to allow people with OpenID Connect token to come in and talk to the Kubernetes API. The clients will just need to set those tokens on their machines. So there are a couple of kubectl commands that they can do, or there is a UI that generates the config file, and you're good to go. So the UI is kind of nice if you're more than a few people. It's a nice helper there. If you don't have OpenID Connect, you have webhooks that are possible, and that's basically every time a token is going to come in on the API server, we're going to call a webhook to verify that token and get information about which user this token is related to, things like groups and such. So this is more like if you're doing a DIY authentication mechanism, maybe you have your own company secret IDP system, I don't know. So this is kind of the 2 main options you have. If you come from a Kubernetes background, you have you're thinking Kubernetes Federation, KubeFed, something that started as Kubernetes back in the days. And here the idea is completely different. It's one API to rule them all. So the idea is to have one Kubernetes API to rule many, many Kubernetes clusters. And this started out as KubeFed v1 that was discontinued recently, and it's not really to be used anymore. And they are working on KubeFed v2, and that's work in progress and will come in beta somewhere before the end of the year. So we kind of are in the in-between situation where if we want to look at the future and be a bit future-proof, we don't really want to go with KubeFed v1, but we can't really go yet with KubeFed v2. So for now, we have to do some DIY stuff with our CI/CD pipeline. And then later on, once KubeFed v2 is ready to go, we'll replace that and go with that. So that's the situation, and things are moving. Then the last layer is the infrastructure layer, where we have OpenStack supporting the whole stack. And in OpenStack terms, we'll just need a few servers, security groups, key pairs, and server groups would be nice. Not all cloud providers support server groups, but they allow you to tell that on those servers, I don't want them to end up on the same physical box. When you run in the public cloud, you don't have visibility on the hardware or the hypervisors. So this is the construct that's available to you to specify that your etcd nodes should be on different boxes. For the networking, we'll just need one neutron network, one subnet, one router, and a couple of floating IPs. So those are like the OpenStack elements that are the requirements to make progress here. So that's the architecture. Now I'm going to talk about the tools to achieve this architecture. And it would be nice if those tools are somewhat cloud agnostic. We'll start with the infrastructure tools that will set up the OpenStack resources. The OpenStack native project for this is Heat, and it works really nicely for OpenStack resources. The thing to think about is if you're planning to do OpenStack and say Amazon as a multi-cloud environment, then you will not be able to use Heat in Amazon, right? So there you will need to use two different tools, one for your OpenStack-based clouds and one for your non-OpenStack clouds. So if you have Heat also has kind of a smaller ecosystem. It's more difficult to find Heat templates on GitHub or find resources to start with. So if you it's maybe a better choice if you already have expertise with Heat. If you're already using it, then it's a good tool. You have Ansible as another option, and Ansible does lots of things, but here I'm really talking about the cloud modules very specifically that allows to create and manage OpenStack resources. So you have a OS server, for instance, and OS floating IP. Those are modules that allow to create servers and floating IPs. Ansible has supports for a lot more cloud providers like AWS, GCP, and VMware. And lastly, we have Terraform, and Terraform is a bit different in the sense that it's a tool dedicated to handling infrastructure as code, whereas Ansible does lots of stuff more than that. So that we can see in the sense that Terraform has features that are more specific in that regard. For instance, when you're gonna run Terraform, it's gonna ask you, this is what I'm about to do. I'm gonna create those resources. Are you sure about this? Yes, no. So this is kind of a nice feature, the concept of execution plans and such. You have even more cloud platforms that are available, some really exotic things there. So you have different options. Ansible is used in many companies, so that's could be something you already know. So that's what I want to say is that use the tool that fits you and your company the best. You just have several options there. For the Kubernetes install, I'll start again with the OpenStack native tool, which is Magnum. And Magnum uses Heat in the background, so if you use Magnum, you don't really need to learn Heat, so that's kind of nice. But again, it's OpenStack only. So that's something to consider. Magnum has a bit of a smaller ecosystem in the sense that it doesn't have an Ansible module or Ansible Cloud module yet, but has a Terraform one. So you need to look at like pros and cons and how you can, which tools you need to pick. If you choose Magnum for your Kubernetes setup, you might want to go with AWS, in which case you can use Kops, for instance. That's a Kubernetes setup tool that's AWS only. So that could be two tools that work hand in hand, one for AWS, one for your OpenStack-based clouds. In the same idea, you have Rancher. Rancher has support for Google Cloud, Amazon, and Azure, but not really for OpenStack. So you could use Magnum plus Rancher as well. If you want something that works with basically any platform, you have KubeSpray. KubeSpray works with OpenStack, AWS, Azure, bare metal, VMware. Doesn't really care about the infrastructure you run on. It's just a set of Ansible playbooks that set up Kubernetes for you. And one nice thing with the KubeSpray is that it comes with a set of Terraform recipes that are working with OpenStack. So you don't even need to learn Terraform in that case. You have kind of a one-stop shop if it's something you're interested in. So those are kind of the main tools. I'm sure there are hundreds more available on GitHub or on the open source community, but those are like the most popular ones, I think. I think that's kind of it for the architecture, the overview, and the tools. Now I'll go into the demo. All the source code for the demo is available on GitLab. This URL, and really 100% of the source code is there. The only thing that's not there is private keys and passwords. So you can really reproduce this at home, and if you have issues, just hit me up. So I'll first explain the setup of the demo. So I set up accounts with 4 cloud providers. I took the list on the OpenStack.org marketplace. And so we have one region in Stockholm from Elastics, we have one region in London from CityCloud, one region is Oslo from Zeta, and one in Montreal with VexHost. We could add a lot more of those regions, and I hope for next presentations we'll have more, but this is a good starting point, I think. I need to give a good shout out to all the cloud providers that helped me. Sometimes there was some things that needed to be sorted out, and really good support from all of them, and I can see that things are working really good. So this is for the 4 cities we have, and I mentioned many tools. I picked a few. This is the things that worked good for me, because I'm running a demo, I need to select something, but it might not be the best fit for you. So I selected DNS round robin as the global load balancer option. It's very simple, so I thought it was a good way. I used the KubeSpray for the Kubernetes installed, and I used the built-in Terraform recipes in KubeSpray for the OpenStack install. All of that is orchestrated with GitLab CI. You can use whatever CI system you want. It's just this is what was easily available. In GitLab CI, they have a feature they call Auto DevOps, and this is just a wrapper around Docker build and Helm install. But you can script that yourself in Jenkins or Zool if you want. All right. So now we'll go to the demo. So this is the repo. We have 4 projects. We have an app project, that's just the demo application. We have cluster project, and that's just what takes care of setting up Kubernetes and all of that. And we have 2 other projects that are utility projects, so a Docker image and a Helm chart. So really the 2 where the magic happens into this clusters project. So I will go into the application first to show you what the application does. So if I, like so. So I don't know if we see the resolution. So it's just a very hello world application that shows the name and an image of the city where this container is running. So right now we are hitting Stockholm, and we have some like black and white photo from Stockholm. And I'll do a couple of loads. Now we end up in London. So Stockholm was Elastics, London is City Cloud, I think, and Stockholm again, Montreal with the Exos, and Montreal again. So like for each load, we are hitting a different region, and there is a bit of a random aspect to it since I'm using DNS round robin, but that's also why I'm using incognito mode, because otherwise Google Chrome is caching which region I'm using. So that's why I'm opening one fresh window at a time. Let's do one more here. Yeah, so now we end up in Oslo, perfect. So we saw all 4 regions. So our application says hello world, and let's say we want to change that to say hello OpenStack. So I will change that into the Jinja template to say hello OpenStack Nordic days, and I'll commit that into master. If you would be, I'm committing into master because it's a demo. I want the pipeline to go quite fast. But in production, you would commit that into a topic branch and then do a merge request, right? So we have our commit, then we'll check our pipeline. Yep, and we'll need to refresh that. Let's see. Yeah, perfect. So it creates a pipeline for us, and it's gonna build the application and deploy it in London, Montreal, Oslo, and Stockholm. It takes a few minutes. So while this runs, I'll demo the Kubernetes federation aspect. So that's the authentication federation. So for this, I'll bring up the terminal over here, and I'll go into the clusters repo. There is a folder called kubros. So you can run kubros.sh, and that starts the UI that takes care of generating those kubeconfig files. Here I have it configured with gitlab.com. So as a user, I'm hitting the web interface to ask me to approve. So I'm gonna like approve this. Then I arrive on the UI. I can download the config file, and that's kubecfg.yaml. I'll close this. Now that I have the config file, I don't need it anymore. I'll move the file from kubecfg into .kube/config. And now I can do kubectl config get contexts, and I can see that I can see like the London cluster, the Montreal cluster, the Oslo cluster, and the Stockholm cluster. And I can simply list the pods into a specific cluster. So kubectl get pods into the London cluster, and we see we have a few pods, and we see that we have one pod that's just 17 seconds ago. So that's the pipeline just finished in London. And we can check Montreal, and we see 28 seconds ago, so it's also deployed there. Here, what I really want to highlight is that we have one config file, and we can access different clusters. From a DevOps perspective, it's really easy to access and to use the Kubernetes API. I've also protected so that this access is only read-only. So if you try to delete a pod from the kubectl API, it doesn't work. It's gonna show us an error message. So delete pods, context, Montreal. Yeah, it says user is not allowed to delete pods. So that can be a nice way for giving access to your developers, so they can see the pods, they can see the logs, they can see the health status, they can see lots of information, and you can limit what they can do. So yep, we have everything deployed. Now it's running some performance tests, so we're not gonna wait for that. We'll reload this page, and now it says hello OpenStack Nordic days. So just in a couple of minutes, we have deployed in 4 different locations in 4 different clouds. So that's the application point of view of the demo. Now I'll have a look at the clusters repository, and So like I said, this is where the Kubernetes clusters are installed, but this is where also they can be destroyed. Setting up a cluster takes around 15 minutes, so I don't really have time to demo that. So I'll demo how to destroy one, and this takes just a few minutes. All right. So right now we are running in Stockholm. So I will try to destroy the Stockholm cluster and then refresh the page, and we should hit another cluster. So that's kind of the idea. So you can see the different clusters. There is one task to create them. I called it deploy underscore name of the city, and another task to destroy it called stop underscore city. So we're gonna click stop Stockholm. Yep, then the task starts. Yeah, great. So we are checking out all the code. And so this will run a Terraform destroy, basically. So that will enumerate or list all the resources we have in Stockholm and destroy them into the correct order. But before we do that, we're gonna update our DNS configuration. So here I'm using the API of my DNS provider to remove the Stockholm IPs from there. I need to wait 60 seconds for the DNS propagation to happen. That way I'm sure my clients don't have any effect. So now we have removed those DNS entries, and in a few minutes it will, or in a few seconds it will do the Terraform destroy that will completely destroy the cluster. And that's really what this does. Great. So now we're starting the Terraform part, listing all the resources. And destruction complete of the key pair. It takes a bit longer than when I tested last time. Let's see. Now we're destroying the networks and all that stuff. Actually, we can already refresh, I think. Yeah, if I refresh already, the DNS record is already updated. We already hit all slow, so that's working great. We can see that we don't have impact for the clients, and now it's finished. So now we have a completely empty tenant into the Stockholm cloud provider, just with one click. Right, that's it for the demo, and I'll finish off the slides. Yep, just a wrap-up part. So I think the kind of the takeaway points I have is that kubefed v2 is not there yet, but it's coming, and that's gonna help a lot. One API to manage many clusters is nice. Another takeaway, or lessons I learned is that OpenStack interoperability is kind of hard. Different cloud providers have different ways to do things. For instance, some might support neutron routers, some might not. Some might support floating IPs, and some might not. And that's kind of tricky to have to deal with all those situations. You also have glance images that are different in every cloud provider, and that kind of becomes an issue with the flavors around the root disks. So kind of everybody does its own thing there, and you have to adapt to those different situations. Last takeaway is kind of you have to think about, are you going to work with a common denominator, like the lowest option of all your providers, or are you going to work with exceptions? And I think this is something you have to balance on a case-by-case basis, feature-by-feature basis, to see which features are most important to you and are worth to spend the extra time to make an exception, and which are not that important and you just drop the feature. So this is it for my presentations. The slides are online, and thanks everyone for your time.
Thank you, Maxime, for your presentation. Do we have any questions? Yes, we do.
So you can see in the Git history how long it took. I mean, so the whole thing I started 2 weeks ago, and I kind of do that on my free time, so like on just here and there. For instance, just last night I added 1 data center or 1 city, so it's kind of fast thing to do. So it was not so time consuming. Yeah.
Okay, more questions? Okay. Ah, there it is.
Were there different kinds of clouds? Was it the same cloud provider?
So this is different companies. If we go back here, so completely different companies based in different countries. So different clouds in that sense, but they all use OpenStack. Yeah.
Okay, we still have some minutes, so so you talked a lot about using Kubernetes. Now, let's take a step back and reflect, and you had this experience with deploying it. Did you miss anything, or would you like to improve something radically with Kubernetes? Like, what would be like one feature that you would say, like, I need this, and one for OpenStack?
So in the demo, there are some things I missed or I skipped intentionally. So the application here, it talks to an API, so it's completely stateless. There's no database other than the API it's talking to. So if you would do this with an application that has a database, you would need to add Cinder integration, and that could be a little bit. I'd say different cloud providers might have a Cinder and some might have Manila. So you could connect your stateful storage differently there, right? So, yeah.
There's someone contributing to Kubernetes there. You could take this feedback. Okay, so let's thank the speaker one more time. And yeah, now we have a break until quarter to 3.
Thanks.